Well, I'd like to thank the organizers for inviting me to be part of this, although I must admit, being part of a lecture series on consciousness is quite surprising for me, since I don't really work on consciousness except in my daily life. And what I'm going to do, and as you just heard, I am unambiguously a basic neuroscientist, and I work at the level of small circuits. So what I tried to do in putting together this talk was to find some of the lessons from our work that I think are definitely generally applicable to human brains, and then to try and sort of show the paths for the importance of some of these ideas. Before starting, I would just like to thank all the people with whom I've worked over the years. And I would just like to say that everything I've ever done is benefits from the brilliance, creativity, and energy of all the people with who are in my lab and with whom I've collaborated. Now, yesterday you heard a little bit about different levels of organization in the brain. We have neurons, individual neurons, and they have their individual electrophysiological properties, that is to say, their activities. We have synapses, and those are the structures that connect neurons and make circuits. And I should say that synapses come in all different kinds of flavors and are quite different from each other. And the characteristics of those synapses are also very important. Then we have circuits, circuit modules, and cells are often put together into small circuit modules with characteristic properties. And one of the things that people like me do is study the properties of small circuits that could be thought of as circuit modules in larger brains. Then you have large interacting circuits and then whole brain function. And there are some really puzzling questions that I think are really fundamental to understanding large brains. And that is question one, is to what extent do the properties at each level of organization percolate to the next higher level of organization? So, phrased in another way, to what extent do the specifics or the details of how individual neurons work or how individual synapses work, to what extent do they shape the properties at the next level of organization? And then to what extent does the next level of organization and those interactions shape the properties of the final level of organization? And then another really important question that I'm sure you'll hear more about later: how does information travel in the brain? So sometimes information may stay quite local to only one region of the brain, and you heard a little bit about this yesterday. And sometimes information travels throughout the brain, and then what governs how it travels. And then the final piece of that is, how does brain state change how information travels? And these are questions that we have studied in one way or another using small circuits, but that are obviously deeply relevant to understanding large brains, including human brains.